Hello! In today's lesson we're looking at inscribed angles, which is chapter 10, section 3. Our objectives are to use inscribed angles to solve problems and use properties of inscribed polygons. We start with some vocabulary. Inscribed angle. An angle whose vertex is on a circle and whose sides contain chords of the circle. The difference between an inscribed angle and a central angle is that a central angle goes through the center of the circle, so you basically have the radiuses that create the central angle. An inscribed angle goes all the way through to the other side of the circle and does not necessarily go through the center of the circle. So this is my inscribed angle in here. Intercepted arc. The arc that lies in the interior of an inscribed angle and has endpoints on the angle. So here are some examples of intercepted arcs. The red part is the intercepted arc. Here we have an inscribed angle, and that's the red part is that intercepted arc of this inscribed angle. This one looks like it might be a central angle, and again we have an intercepted arc, and here's another example with an intercepted arc. Inscribed polygon, a polygon whose vertices all lie on a circle. In an inscribed polygon, you basically have a circle, and within that circle you have a polygon where all of the vertices of the polygon touch the circle. Circumscribed circle, a circle with an inscribed polygon. Theorem 10.8. Measure of an inscribed angle. If an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. So the measure of angle ADB, which is this angle right here, is half of the measure of arc AB. The way I remember this is I think about an ice cream cone. So angle ABC looks like an ice cream cone, and arc AB is the ice cream on top of the cone. The angle measure of the inscribed angle is half of my ice cream because it's smaller, and then the arc is 2 times of my cone because it's bigger. Theorem 10.9. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Angle C is congruent to angle D because they have the same intercepted arc. Angle D has arc AB, and angle C also has arc AB. Example 1, measures of arcs and inscribed angles. In this example, we have to find the measures of the arc or angle. So problem 8 says find the measure of angle XYZ. XYZ is the inscribed angle, and we know that the inscribed angle is 1/2 of the arc measure XZ. We know that XZ is 140 degrees, so half of 140 is 70 degrees. Problem B, we are to find the measure of arc PQR. So from P to Q to R. That's the top of my ice cream, so I know that that's double the angle over here. So the measure of arc PQR is 2 times the measure of angle PSR. We know that the measure of angle PSR is 80, so 2 times 80 is 160 degrees. Example 2, finding the measure of an angle. It is given that the measure of angle Y is 62. We need to find the measure of angle Z, which is this one over here. Angle Y is an inscribed angle, and its intercepted arc is WX. Angle Z is also an inscribed angle, and it too has the intercepted arc of WX. So we know that angle Y is congruent to angle Z. And since the measure of angle Y is 62, that means the measure of angle Z is equal to the measure of angle Y, which is 62 degrees. By the way, this is theorem 10.9. Alright, checkpoint problems number 1, 2, and 3 are yours. For each of these problems, you are to find the measure of the arc or angle. In problem number 1, find the angle measure of M and P. For problem 2, the arc measure of RVT. And problem 3, find the measure of angle A. Theorem 10.10. If a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So in this picture over here, angle B is a right triangle if and only if line segment AC is a diameter of the circle, which we know AC is the diameter because it goes through the center of the circle, which means that angle B is my 90-degree angle, and this is a right triangle ABC. Theorem 10.11. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Remember, supplementary means two angles that add up to 180 degrees. D, E, F, and G lie on some circle with a center C if and only if the measure of angle D plus the measure of angle F is equal to 180 degrees and the measure of angle E plus the measure of angle G is equal to 180 degrees. Example 3, using theorem 10.10. In this example, we are to find the measure of x. We're looking at this circle and we see that line segment SV is the diameter of the circle, which means that this angle over here, angle T, is my 90 degrees. So angle T is a right angle and the measure of angle T is 90 degrees. You can say that 15x is equal to 90. Divide by 15 on both sides, and 90 divided by 15 gives me x equals 6. Okay, checkpoint problem number 4 is yours. In the diagram, WXYZ is inscribed in circle with center P. Find the values of x and y. I'll give you a hint. You need to use theorem 10.11 to solve for the values of x and y. Alright, that's it from me. I'll see you all soon.